Hey guys, it's Mrs. Hoekstra. So today we're going to do a pumpkin launch. Well, not physically do a pumpkin launch, but have a problem about launching pumpkins. So please go ahead and put this in your notes that our lesson today is called Pumpkin Launch, and put today's date on there if you would as well. While you are doing that, I'm going to go ahead and show you a video of pumpkins being launched. I actually find this to be quite fun. I do actually watch this when it's on television. It's usually on around Thanksgiving time. Here you go.
Fall is in the air. Temperatures plummet, leaves cascade to the ground, and pumpkins fly through the air. Yes, November means it's pumpkin choking time in Millsboro, Delaware, when post-Halloween pumpkins are turned into projectiles. It's all part of an annual contest to see whose contraption can launch a pumpkin projectile farthest.
All right, so there we go. There is your pumpkin chunkin'. So let's suppose that we are going to launch a pumpkin from a height of 7 meters. If you would do me a favor, write down height equals 7 meters, right? Height equals 7 meters. And if you are like most middle schoolers, you have no idea how tall that is. So think of it as roughly, it's leaving our device, our trebuchet, our catapult, our air cannon, whatever, at the height of the roof of our building, okay, of this middle school building. All right, and it has an initial upward velocity. So it's leaving our device, the velocity is 24 meters per second, right? So let's write that one down. Velocity, right? That's the speed. The velocity is equal to 24 meters per second. AKA, it's going to go across 2 classrooms in 1 second. Okay, just to kind of give you an idea of how fast that is. Across 2 classrooms in 1 second. Then, of course, there's this lovely thing called gravity, because, of course, these pumpkins are going to have gravity pulling on it. Gravity is negative 9.8 meters per second squared. That is not a made-up number. It really, truly is negative 9.8 meters per second squared. That is truly what it is. When you are in physics class in high school or in college, you guys will see that number constantly. It's obviously gravity. It's going to change if we were on a different planet or if we were on the moon. So now, all projectiles, every projectile in the world uses this equation. Do not write this down. Uses this equation right here to calculate where it is in height with respect to time, right? Where is your projectile? How high off the ground is it with respect to time? So we're going to take this, we're going to take our information up here, and we're going to put it together and write an equation. Hopefully, it's one of the ones that I have on my screen. All right, hopefully it's one of these. So here we go. We're going to calculate the height. So we're going to have the height is equal to, and I'm just going to follow my way through this expression here. That part right there is 1/2 of the gravity, negative 9.8, right, times time, and I don't know what the time is, squared. So I'll use t for time. I don't know what it is. Plus the velocity, well, we wrote that down. We said velocity was 24 times the amount of time it's in the air, plus the initial height, plus the 7 meters it was off the ground when we launched our pumpkin. If possible, it would be nice to simplify this, because when we want to use an equation, it's nicest if we can get it simplified. The only thing I can simplify is that piece right there. So h is equal to half of negative 9.8 is negative 4.9 t squared plus 24t plus 7. Now, if you look, those are choices that I have on my screen, right? I have that. I have what? C, and it appears to be E. You do not have to write those down. I am happiest with these. All right, that's what I'm looking for. So now, I want to take this, and I would like you to write down all of the terms. I'm going to rewrite it on my next screen. Okay, I would like you to write down There it is. You still have it on yours, hopefully. I want to rewrite this. I would like you to tell me, what are the terms? What are the terms in that equation? All right. What are the factors in that equation? And what are the coefficients in that equation? I'm going to give you a few minutes. Go ahead and press pause. And when you're ready, go ahead and let's see what the answers are. Now, if you couldn't remember what they are, terms, factors, coefficients, those were all vocabulary words on our second or third lesson of this unit. Terms are separated by addition. Okay, they're separated by addition. So in that case, that means that my terms are negative 4.9t squared, 24t, and 7. Those are all of the terms because they're all separated by addition. Factors are things that are being multiplied, right? Are being, that helps to spell it right, being multiplied. So in this case, negative 4.9 and t squared are being multiplied. And in this equation, 24 and t are being multiplied. Those are factors. And then coefficients. Coefficients are the numbers with the variables. Numbers multiplied to a variable. Okay, so in this case, the coefficients are negative 4.9 and 24. Hint, you guys are going to have a test. This is an incredibly good thing to know, understand, and have nailed down. Just a hint, hint, hint. All right, so let's go back to what we have going on here. All right, we've got this equation. You guys, if you need to, you may want to switch to another page. We are going to make a table and a graph right next to it. Okay, and if you need to, we're going to have to hit pause. You need your graphing calculator that is up on the wall over there. So go get it if you need it. All right, we're going to make a table. Our table is going to keep track of time and height, because that's what the equation is all about, time and height. So our time, we're going to keep track of 0, 1, 2, 3, 4, 5. Let's go to 6 seconds just to see what happens. If we need to add more, we can. So then what I'm going to do is I'm going to plug all of those numbers in to this equation right here. We're going to plug them in. Okay, now this first one, hopefully you don't need to use your calculator. Okay, just watch. Watch me do this. H is equal to negative 4.9 times 0 squared plus 24 times 0 plus 7. Now, of course, you guys are smart. You know that that's 0. You know that that's 0. And the answer is just 7. Now, this next one, I do want you to use your calculator. I will go slow. So turn your calculator on. And we're going to know that the height is equal to, now the negative is next to the enter button. So you have to press that in. And then 4.9. You're going to open parenthesis. I believe it's above the 8. And then you're going to type in 1. You're going to close the parenthesis, which is right next to the open parenthesis. And you're going to press squared. The squared button looks like this. And it's diagonal from the 7. Right? Here's the 7 key. Diagonal from that is the squared button. And then you're going to press plus 24, open parenthesis 1, close the parenthesis, plus 7, and press enter. When you do that, to the nearest tenth, we should get 26.1. All right, let's try the next one. So we're going to do the same thing, negative 4.9. Negative is next to the enter button. Open the parenthesis. Press the number 2, close the parenthesis, hit the squared button, which is diagonal from the 7, plus 24, open the parenthesis, 2, close the parenthesis, plus 7. Make sure your screen looks like mine. Press enter, and you should get 35.4. So let's try it again. Do the next one. Type in negative, which is down by the enter, 4.9. Open the parenthesis, type in 3, close the parenthesis, and square that. Plus 24, open parenthesis, 3, close the parenthesis, plus 7. As long as it looks just like mine, you should get the same answer as me. And I get 34.9. And most of you are freaking out, going, hold it, that's smaller. Let's think about what a pumpkin does. Pumpkin's going to go up and eventually come back down. So it makes sense that the numbers are going to start to drop now. All right, let's try it again. Negative 4.9, parenthesis, 4, close the parenthesis and hit squared, plus 24, open the parenthesis, times 4, plus 7. When you hit enter, you should get 24.6. Now let's do it again. This time put 5 in. Negative 4.9, parenthesis, 5, close the parenthesis, squared, plus 24, times 5, plus 7. And I get 4.5. So in other words, at this point, that pumpkin is about at the ceiling of this room. Remember, it left at the rooftop, and now it's at about the ceiling of this room. So it is definitely coming down. Now 6, I don't have this exact, so we're going to have to take a minute. Negative 4.9 times 6 squared plus 24 times 6 plus 7. And we get negative 25.4, which doesn't really make sense logically, because obviously that means it's smashed. But if we had a lake or an ocean or a river or something nearby, and maybe it fell into that and it could go that deep, right? But obviously it's going to hit the ground somewhere in here, right? It's going to hit the ground. All right. So now what I want to do is I want to graph this. Okay, I'm going to take that data and I'm going to graph it. And make sure your graph goes down at least 8, maybe even 10 lines down. Okay, and then let's go across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I'm good. Okay, and so my 2 variables I'm keeping track of are time, and we're measuring that in seconds, and height, and we're measuring that in meters. All right, it's important to have those. Now our time we measured in seconds. We could, if we wanted, spread this out and have half seconds in there, but let's just make life easy on us and let's just count by ones. No big deal. So we have 0 seconds on that line, 1 second, 2 second, 3, 4, and 5. They go on the line, not on the spaces. Now our height, if you look, we've got to get from 0 up to at least 35.4. Right? So I want to go bigger than that. So maybe aim for like 36 or 40, right? So I think what I'm going to do is I'm going to count by 5s. But if you've been in the class long enough, you know that Mrs. Switzer is very lazy. So I'm not going to write them all down. I'm going to skip the 5 and I'm going to write the 10. Skip the 15, write the 20. Skip 25, write 30, skip 35, and write 40. All right? I'm too lazy to write by 5s. I am there. They are counting by 5s. If you want to put them in, go ahead. Feel free. All right, so now I'm just going to take my data from my table up above and I'm going to graph it. So at 0, it's at 7 seconds. So it's between 5 and 10 is 7. 1 second is at 26.1. So here's 20, 25, 26.1 is a little bit higher than that, right? A little bit bigger than 25. At 2 seconds, it's 35.4. So here's 30. Here's 35.4, just a little bit higher than that spot there, and that line. At 3 seconds, it's 34.9, so it's just below that 35. At 4 seconds, it's 24.6. So 24.6, just a little bit below it. And at 5, it's 4.5, so just a little bit below the 5. Again, go ahead and hit pause if you guys need to and get caught up to me. I am going to connect it, but this is obviously not a line, so I'm not going to try to make it look like a line. I'm going to give it some kind of a curve, and if you think about pumpkins going through the air, they go up and they come back down. And it makes sense that this graph is doing that. Now, the thing is, this graph does not represent the height vertically and the height horizontally. This is the height with respect to time. In fact, this pumpkin could have possibly gone just straight up and came straight back down and just smashed into the ground. All right. All right, so we've got our graph. So I want to know about how long was the pumpkin in the air? About how long was the pumpkin in the air, right? It hits the ground down here. So the pumpkin was in the air a little more than 5 seconds, right? It's pretty obvious even if you look on the table, right? Somewhere between this 4.5 and negative 25.4, definitely closer to 5 than 6, right? It hits the ground. So it's in the air, let's put it that way, in the air about 5 seconds, right? A little more than 5 seconds. Okay? Where was the pumpkin in 1 second? At 1 second, it is, where did we say? 26.1 meters up. Right? Remember, a meter is about a little more than 3 feet, guys. This is up pretty high, right? This is up pretty high. I want to know, when was it at 25 meters? When is it 25 meters high? When is it 25 meters high? Best way to find this is to actually look at it on the graph. 25 meters, right? 25 is right here. So I want to know, when is this? Right? When is that? A little bit before 1 second and a little bit before 4 seconds, right? It is 25 meters about 1 second and 4 seconds, right? Just about. We're not getting exact. We'll do that later this year. But right now, we're just kind of estimating. So a little bit before 1 second and a little bit after, a little before 4 seconds, that's where we're going to find that pumpkin, right? It's there twice, on the way up and on the way down. All right, so that is my entire lesson. Your homework is in Google Classroom. It's only 4 questions, so it shouldn't take you too long. Go ahead and put your calculators away, and see you guys later.